Tech Talk Tuesday. Number 135, y'all. Everybody sign up. Let's roll. I just about was a tiny bit late, but I made it. Hey, Brad. Hey, Alan. Chuck. Thanks for tuning in, Chuck, Alan, Brad, and all y'all. I appreciate it. Brad and 6 others. David, Alex. Oh, and 6 other people. Hey, Daryl. I appreciate y'all calling me a kid. I know better. Charlie. As always. Alan. Cash. As always. You gotta tell me about that name one day, man. K-A-S-H. David, Alex, Tom, Justin, Timothy, Tom Grooms. Hey, thank y'all. 135 weeks in a row, y'all. We've been meeting here on Tuesday. I think it's 6 o'clock over there in Georgia, up and down the East Coast. It's 5 o'clock here in beautiful Tennessee. Chris, Greg, Mark, thank y'all for checking in. Another Charles, Ed. Great, Darren. Good to see you, Brian. I appreciate you guys tuning in. I know I waste a little bit of time talking about my friends and my people tuning in here. We got, I think there's 5 of you, man. There's, let's see, there's my faith, my family, my friends, my followers, and my frenemies. Yeah, there's 5 of you. Times how many of you there are. A little bit. Faith is big for me. My family's awesome to me and for me. And then my friends that are my real friends. Hey, Kevin and Donald and Brian, James. And then you got the followers, which are cool. Everybody needs somebody to follow them. I hope you lead them good. If somebody follows you, you got to lead them good, man, because that's a responsibility some people don't take lightly. And then you've got the frenemies. And then what is there? I said them the first time. Let's get them right. We got the faith, the family, the friends, the followers, and the frenemies. Okay, that's all 5 of them. Thank you all. And I know just about everybody, some of you are admittedly that to me, and everybody else has their own 5. All of us, we have our 5. Sorry about my nails being dirty, but I did work a little bit for being a retired man. I'll talk a minute real quick about being retired. I just want to tell you that I'm retired from building engines and handling clients' work and the creditors involved and the team members, employees involved at Star Racing for 42 years now. I am retired, and I get to do stuff more like what I want to do, when I want to do it, and still working. That doesn't mean I quit working. I just work more on what I want to work on and what I enjoy working on. The good Lord's given me that opportunity to work on the things I love, and making engines go fast and learning about how engines work, and we're learning about how to make them run better, make more power, last longer, we love miles per gallon. We love to, transportation is an event for me. It's not just a necessity. Whatever I drive, whatever I own is, it's like going to Six Flags. It's like going to the fair and riding the rides. Like I said, it's an event for me. It's not just a mode of transportation. I'm a G freak. I love the G force. I love the coil bind springs. One day, the late great John Lingenfelder and I were riding in a Viper that he built for me. That was his team over there at Lingenfelder Performance. Built this stroker engine for my Viper, normally aspirated Viper, made a lot of power. I asked him that if it would coil bind the springs. He said no. He said we set the valve train up and everything to where it won't. And I said no, I'm talking about the coil springs in the seats. I'm talking about the seats we're sitting in. When I floor it, I want it to coil bind the springs in the seat. That's what kind of G-force I love. Excuse me. He got a kick out of that. We stayed friends for a long time, but yeah, man, you gotta coil bind the springs in the seats. And I see some really fast Harleys and drag bikes guys have going now in cars that have not much spring in their seats anymore. A lot of people have solid seats, and I see some of those solid aluminum seats you guys have on those fast Harleys, man. They can't be too comfortable for a while. I don't have enough padding in my derriere anymore. I have to put padding in the motorcycle seat. And my car, I love that too. I love my car to smash the seats. Paul Gass, great friend, great guy, really smart champion racer, told me one day, he said, when I floor the car, when I floor my Porsche, he had a twin turbo Porsche. He said, when I floor it, I want it to break the seat right off. I want the, he said, when I floor it, I should fall in the back seat of the car when I floor it. That's when it's got enough power. Anyway, thanks for tuning in, you guys. I will try and get a little more technical now. I wanted to go ahead and tell you about a mistake I made last week that I should have known better when I was telling you about curtain area. I left some of this up here. I will erase it as we move on. But last week I taught, and I wanted to try and explain to you guys that I really do learn when I talk this stuff to y'all. It's easy to say I'm teaching, but I want to tell you I'm learning. I am learning how to explain this stuff in a way that many can understand. That is definitely a chore for me, is to learn how to tell stories, learn how to translate this information into something useful that may stick to you, like a good meal. You want it to stick to you. You don't want it just going one ear and out the other. This formula that I used last week, it was diameter of the valve times 0.96, and it wasn't 0.096. I think it was 0.96. It's wrong. It is 0.98. That's where I was wrong. George Baber told me that. I appreciate it. He said he loved the whole show. He just felt like he needed to share that with me because he did the math about 10 times. It's the diameter times 0.98 times pi, which is 3.14 times lift, was not 3.76 square inches. I mean, curtain area. It's 3.84 inches of curtain area. And for you that didn't watch, here's curtain area again. 600 lift here. The diameter of the valve times pi times the lift gives us this curtain area. So if we made this curtain, I'm gonna get a piece of paper and show you. You can take this and make a curtain out of this. This is very unprepared, so. The valve diameter times the lift, and when you open up that curtain, it would be that long. So it would be 3.84 square inches of area in this curtain area. So I just wanted to correct this math. So if you wrote it down, please go back and look. I had diameter times 0.96, which is wrong. It's 0.98 times 3.14, which is pi times the lift. And I used 600 as an example, and I came up with the wrong number. I came up with 3.76, but it was actually 3.84. All right. We can go over that another day. Today we're going to talk about a little bit something else. And I wanted to share with you guys about custom pistons. Now, we all have to have pistons for our hot rods. We have to have shelf stock pistons, Chevrolet pistons, Ford, Chrysler, whoever, Mopar. We got to have Kawasaki, Suzuki, Yamaha, Briggs & Stratton, Seal Power, Total Seal, CP, Venolia, Arius, Diamond, Wiseco, JE, Gibtech, name them off. I forgot one of them. Wassner. So many great piston companies out there. And I wanted to share with you guys that when you have a custom piston, what is a custom piston to you? Is a custom piston where you call the guy up and you say, I want this diameter, and I want this compression height, and I want this size rings, and I want this kind of dome, and I want these kind of valve pockets. Is that a custom piston to you? Like, to me, there's not a shelf stock piston like this out there. This is a pro stock V-twin, 5.1 bore, 5.14 bore. It's got a million measurements on it, and we only measure what we know to measure. Right? Why has it got a notch there? Why is it a full skirt there? What is the major thrust? What is the minor thrust? What about wrist pin offset? What about compression height, center of the wrist pin to the top of the piston? What about valve pocket diameter, valve pocket location, valve pocket depth, cant angle, offset, spark plug notch, cc's of positive or negative dome volume, and I'm talking right off the top of my head. Ringland diameter, ringland thickness, top ringland. Here's a list of when I was racing full time. This is a list of some of the things that we would do. We would do the bore diameter, the piston size, compression height, effective volume, dome height, intake pocket diameter, intake pocket depth, exhaust pocket diameter, exhaust pocket depth, top land thickness, top ring groove axial height, top ring groove depth, top land diameter, top ring groove root diameter, second land thickness, second land groove axial height, second ring groove depth, second land diameter, second ring groove root diameter, pressure balance groove width, third land thickness, oil ring groove axial height, oil ring groove depth, third land diameter, ring land ovality, oil ring groove root diameter, skirt profile, which there's 50 of those, cam profile, there's about 50 of those. You get to call them out which one you want. Skirt measure point, wrist pin diameter, wrist pin length, wrist pin lock type, crown thickness, skirt thickness, pin ball spacing, pin fit clearance, piston overall length, finished weight, and coatings. And guess what? There's 2 more pages. That's a custom piston in my world. And I wanted to share that with you because when you call up and order a set of pistons from a piston company, there is so much standardization or averaging done over sales history for those guys. And I'm not in the piston business, and I'm not a piston manufacturer, but I know a lot of them. I am great friends with a lot of them. Been in the business for 40 some odd years, so I've watched them come and go. I watched them grow. And like I said, I've developed a great relationship with a bunch of them. But I wanted you to know that those numbers, if you don't call them out, then a guy that makes the parts calls it out for you. So you are ordering a custom piston based on what you know to measure. Or anyway, I just wanted you guys to know there's way more to it than. And if you were a real, like you were trying to win in pro stock, you didn't have nitro or a blower or a turbo, and you only had these things on these pages to use to find 1 more horsepower, you would change these along the way. You would work on how thick this top land had to be. You would have to figure out how much radial clearance you had behind the ring, then how much axial clearance beside the ring. It was up to you, because if it was wrong, you can't call this guy up and say, hey, guess what? You made that piston wrong. No, the only way they would build something this weird for me was for me to call out the numbers, because that was my responsibility for it to be wrong. Now, you guys are really good at pistons and racing know that this wrist pin is too far away from the top of this piston. And now that I have after 2016 here in 2022, I would have done this probably 20 more different ways. One year, we were fortunate enough to make 15 different designs of this to figure out how to go 673 back in the day. And they were, we just learned. We learned it every time we would move. We would move this. Another thing we learned that is on another page is center balance. This piston is made in a model on a computational dynamics design program, where if you were to put this on a center point and stand it up on a point, this piston would stand here by itself. It's perfectly center balanced so that when it goes to the top, it won't have one side rocking over the other, where it comes to the top on overlap and it just rocks over, or it gets sideways and it keeps these rings from staying sealed to the cylinder. So center balance is very, very important. And the higher the wrist pin is, as long as you have real estate to get all the rings in where it all matters how good it seals, as high as you can get the wrist pin in, the less, I'm going to use a word I just invented called slingability. For this to just sling, it'd be like a seesaw where it has the pivot point would be higher up, so it would have less rock. Back in the day, back a long time ago, when we only could get 1 length rod for whatever engine we were building, 5.7, 5.6, 6.13 or whatever they were for big block Chevys, and the whatever that rod length was and the block height, you know, we would deck the block to 0, but these pistons would have the wrist pin down here, and it would have so much real estate up here that the piston never could keep the rings sealed up well at high RPM. So there's a lot of learning that's going on here. And now if you'll look, you can look real close and see there's a 7-degree angle on this dome that we would machine in the head to try and convince all this mixture out here to run over here and get in this little chamber and let these spark plugs have a go at it. Excuse me, I got to cough a minute. And get some 0 weight O2. I got to put a little 0 weight lube in it. Oh yeah. So the evolution. What does all that racing have to do with me? What does it have to do with you? What does it have to do with your car, your motorcycle? Well, the good news is, over all this time, these numbers have been averaged, all of these different dimensions. And then it's not, I haven't even mentioned what rings. The rings is another science just like this. And I'm going to give you a tip. This is the greatest engine building tip that I've learned, and I wasted a lot of money doing this wrong. But when you're building a new engine from scratch, whatever it is, get the rings. Get the rings. I'm not saying call up the piston company and order the rings. I'm saying if you're going to have custom rings, or you're going to have a weirdo engine combination, the bore and the stroke, compression height, how much real estate do you have right here for the rings? You want the most you can get to get good ring seal. So you're going to have a special bore size. You're going to have a special ring size. And you're going to need to be holding the rings in your hand, or you're going to have to get Lake or Keith or those guys over at Total Seal or wherever you buy your rings. You got to get that guy to have your ring, your part number, your dimensions. You got to have your ring in your hand. Second thing you do before you ever talk to this guy is you got to have the head gaskets, because you got something weird going on. It's not a Chevrolet. It's not a 4 1/4 bore. It's not a small block Chevy with a 4-inch bore. I'm talking about a real custom engine that's like you're blazing a trail. You got to have the gaskets, and you got to have the rings, and then you can work on the pistons. I did it wrong all those years, man. I said, I'm going to get me some pistons, because that's the hard part. And then I get the pistons made, and then I'd mess around trying to find rings, or I'd like call up Comatic and say, hey man, I need this gasket. We don't make that gasket. Would you like us to design you a gasket? And then you have to send them prints of the head and the cylinder. You have to send them the prints of every part of the mating surfaces, and then they design a gasket, and then you have to sign off on it. And you got to sign a piece of paper for the piston, you got to sign a piece of paper for the rings, and you got to sign a piece of paper on the gaskets that says if it fails, if it don't work, if it doesn't fit, it's on you. How many times did I learn to pay that? Yeah, I just see that right there, Brian. That's a good point. I think when it all said and done, while we're doing our little ideas of rules and tips, remember, get the rings first before you talk about the pistons. Get the rings first. Make sure you can get the rings. Make sure they're actually made. I'm going to tell you something, man. I have been in motorcycle engine building for my whole life. I've done lots of car engines too, and every other kind of engine, lots and lots and lots of them. But I have had to pay out of our Star Racing money for rings that were never made. We've had to have custom rings made because I designed the engine around a piston idea or a crankshaft idea or a cubic inch rule idea, and never considered that there was a ring problem or they weren't even made. And I think back in the day when John Myers, the late great John Myers, was racing for us, we had a special bore and stroke combination. Tom Falicon made a stroker crank for our Suzukis. We had pistons custom made, and I had to pay money for a stack of rings about a foot long. No, it was more than that. It was like 4 1-foot-long sleeves of rings to fit that bore size. I had to have, we even had some really nice Molly field rings back in the day when that was the coolest thing you could get. And when you get a little thin ring, and you get it Molly field, let's say it's like an 032 ring, for instance, this is what the cross-section of that ring would look like. And then they would have it filled with Molly. And I'm talking about only 032 here. And I think they make even cooler stuff than that now, but these rings, like this one right here, this ring is way smaller than that. This top ring on this 5 1/8 piston here is about as thin as an oil rail was back in the day. But they are more conformable. They follow the cylinder shape more, and as long as they're thick enough to take the heat out of this crown and transfer it into the cylinder, they work pretty doggone good. Back in the day, we could only buy rings whatever were sold. 16th, 3/16, 062s, whatever the ring was available. Then you started having to make homemade rings, homemade ring lands. Boy, we've gotten so much better than that these days. But I could say you could save you some money if you get the rings, get your hand on the rings first before you start getting the rest of the stuff. At the end, when the rules say you have a cubic inch limit, it can only be X amount of cubic inches. I always use the biggest bore I can fit where a head gasket will work, and I can get rings, and I can also buy a piston that would have the biggest bore. And then we would make the stroke to whatever fill the cubic inches. The biggest bore would be whatever would fit real estate wise for the gasket, the studs, the block, whatever the limitations were for the bore. We would set that as our maximum based on real estate and architecture of the engine. Then we would go down and figure out what the stroke needed to be to make the cubic inches. Then we would work on whatever was left was the rod length. And it didn't matter if that rod was this long or this long or this long or this short or this short. As long as there was room, that was last on our list. Now, the guys that read the books that are talking about rod length matters, because today I had a conversation with a guy, a really smart guy, and he was talking to me about all the guys talk about, the old guys that have been around forever. They say you got to have really, really short rods to pull the piston away from TDC quicker so that you can get a toe on the cylinder head. Well, if you do the math, do some real math of how far the piston moves per degree, and you do a 1/2 inch long or a 1/2 inch shorter rod, it's almost immeasurable how much faster, and the piston's moving away from TDC, and they're worried about getting a toe on the port. Well, look and see how big the valve is open there. I mean, the valve is only 200 off the seat. The valve is only 300 off the seat. And if you got an engine where the piston's at TDC and it starts moving away and you're worried about how fast it moves away, please go look at where your valve is, your intake valve. It's going really slow, and it's sitting close. It's still in the chamber. I mean, the intake valve is still down in the chamber trying to get up out of that hole where you're worried about how much toe, the rod length, moves the piston away from TDC. And the flow bench, if you were to flow the head right there, and where you're worried about this rod length helping it toe on the intake port, if you were to measure on the flow bench how far that valve was open right then and worry about what the flow is, you'd be surprised, because it's still inside the chamber. It hadn't even come out of the hole yet. And that rule was invented a long, long time ago, in my opinion. These are all my opinions. That rule was invented back in the 50s and the 60s, back when everybody used a stock cast iron head. Even at Daytona, even at the fastest race cars in the world, they were running factory cylinder heads, especially production car races, production engine races. They were running cast iron heads where you had to micro manage everything about it to get a little bit more airflow and 1 horsepower more than the other guys, because they couldn't do a better head. They couldn't do the really cool stuff we have now. The better the cylinder heads are, the less that rod length matters. And you need to worry about way other things before you worry about that. And that's me preaching on rod length. Well, that doesn't make people happy that love the rules that were written years ago. Why is this piston notched on this side and it's not notched on this side? Why is this piston notched on this side and not on this side? Well, this is old news for savvy engine builders, but all the pistons during their work that they have a major thrust and a minor thrust on the skirt, every piston. And on whatever piston it is, if it has a major thrust here and a minor thrust here, that never changes on that piston, because crankshaft's going this way, and when the piston's going up and down on the power stroke, it's trying, the crankshaft's going, and the rod, when it gets under extreme angle and load, the piston's trying to come out the back. So this is the major thrust skirt. And the minor thrust skirt is on this side. So we don't ever notch the major thrust side of a piston. And the reason these are notched is because they have to clear each other at the bottom. These, on a V-twin, they go like this. So if you have a V-twin pistons and they're notched on the front of the back piston and they're notched on the back of the front piston, that's hard to say. Let me make sure I said it right. If you have a pair of V-twin pistons and they are notched on the front of the rear piston and the back of the front piston, one of them's notched through the major thrust, and it will not hold up as well as one that is designed to where you have the major thrust on every piston is as big as it can be to handle the load. And the minor thrust, sounds like I'm teasing, but I'm not. This is, I just got a little bit lost there. So it's like this right here. The rear piston and the crankshaft, and here's the connecting rod. And then the front piston, and here's the connecting rod. This is going this direction. I hope you can see this. So when this piston's going down, it's leaning on the back skirt. So this is the major thrust on the rear piston. And when this is going up and down, same thing happens when this gets to the bottom and the crank's over here and it's got this angle, it's still trying to shove this piston out the back. So the rear of the front piston is the major thrust skirt, and the rear of the rear piston is the major thrust. V8, let's do a V8. Look at it from the front right quick. Like I said, this is old news to you savvy guys. 4-inch crank, 90-degree V8. Looking at it from the front of the engine. Harmonic balancer is going this clockwise. This piston's going up and down. This piston's going up and down. And this piston right here, when it goes up and down, it's trying to push out the back, which is the lifter side. The driver's side is trying to push the pistons towards the lifters. The passenger side is trying to push the piston towards the exhaust. So on a V8, the driver's side would have thrust on the major thrust on the intake side, and it would have minor thrust on the exhaust side. On the passenger side, it would have major thrust on the exhaust side and minor thrust on the intake side. Just know that. You can design pistons to know with that involved. You can use that to your advantage, and it's fun. It's fun to know that. It's fun to use that. Got to go to Mardi Gras, huh? Okay, y'all have fun, Millie. I just wanted to come in one more time, and I'm gonna go on the camera here for a minute. Please disregard the noises. Here I am with a lampshade coming out of my head. How's it going, everybody? We're coming up on the end of Tech Talk Tuesday, number 135. 135 weeks we've been talking about these hot rod parts, hot rod engines, and the shorter the rod, the more side loading you have. That's right, Ed. And you need to know where it is. It's at somewhere between 70 and 78 degrees after top dead center on the power stroke. Is when it has the most thrust. Shorter the rod, the more angularity it has. So a long rod helps that angle. And some people want a short rod because of some reason. Some people want a long rod because of some reason. I like the biggest bore I can use and the crankshaft that makes the engine legal. And then however that stacks up, I like the rod to be whatever length it needs to be. And you also have to keep in mind push rod length if it's an overhead valve engine. Long push rods, like long rods, they fit, but the longer the push rod is, the more of a pole vault you have, and how hard it is to keep that up, so you got to keep that in mind. But a short rod gives us a chance for short push rods. It gives us a chance for a low center of gravity package. But if it was a dyno contest, I don't think it would really matter how long the rod was or how short the rod was, but there are advantages. Short rod lets you have a shorter push rod. Long rod lets you have less angle and a peak cylinder pressure, and all that stuff matters. And I did have other subjects I wanted to carry, but I got really carried away with the tech talk on the piston skirts and the piston and the information you have to come up with to get custom pistons. Now, call up your piston guy, order your pistons like you always do. He obviously knows through research and development and experience that what he sells you works, but that is not exactly a custom piston. A custom piston is when you are responsible for all the dimensions, the alloy, the barrel shape of the skirt, the cam grind of the skirt, where the minor thrust is, where the major thrust is, and what the pattern looks like when it's worn. You get to dictate all of that with the shapes and the sizes of all the dimensions. And it's okay if you don't know this, because you do what you do, and this is what I do, and I'm learning it every day. And I love sharing this with you guys on Tuesdays, Tuesday evenings. This is 135 times in a row, and I'm looking forward to doing this as long as I can. And as long as you guys keep checking in, keep sending me questions, keep giving me feedback. I take negative feedback as well. I've got guys show me where I was wrong, and I'm even cool sharing that you're the one that found me wrong. I have no problem with that. I'm not trying to be right. I'm just trying to share what I think I know. These are my opinions based on what I think I know, based on the parts I ran over in my career and the things that I wasted as much money as I could. When I was in the peak of learning my piston designs, my credit cards got burned up on fire. They would actually warp from heat. I had to put a dual intercooler on my credit card to keep it from catching on fire. I was kidding. Y'all have a great evening. May God bless y'all. Thank you so much for tuning in on Tech Talk Tuesday. I look forward to seeing you next Tuesday. Same time, same place, 1:36. May God bless. Good night.